Okay, this is a short video for EET250L, experiment number 9, a simple PID feedback controller. This is very similar to the video you have just watched. It's in the early part of the experiment write-up. The only difference here is I've used two proto boards to take and have the LED on one proto board. It's now a red LED. The picture before I had a yellow one, but I got the red one in there. And on the other proto board has the photoresistor on it, so you can align them a little more carefully. So what's happened here is a couple differences between what you saw in the video. I've got a blue potentiometer over here as opposed to a 1000 ohm resistor. I do have a 220 ohm resistor like the video over here for the LED. So what happens is the LED is driven by this yellow wire which comes out of pin 5 over here on the Arduino. This is digital pin 5, and that outputs a pulse width modulated signal. So the whole idea of adjusting the brightness of the ambient light that falls upon the light that falls upon the photoresistor is that we'll adjust the brightness of the LED by driving it with a varying duty cycle pulse width modulated wave or signal. So again, what happens here is the photoresistor has plus 5 volts coming this red wire on one side of the photoresistor. The other side of the photoresistor is connected to the potentiometer. The other side of the potentiometer is connected to ground. The yellow wire comes over here to the other side of the potentiometer, and this is a common point where we have a lead, another yellow wire going off to A0, the A to D converter on the Arduino red board. So the photoresistor puts out a voltage proportional to the intensity of light hitting it, and it turns out that the A to D converter, A0, changes that to a value between 0 and 1023. So if we say set a set point of 600, what will happen, you could take and figure out that's about 6/10 of 5 volts, which is about 3 volts. So what will happen is the pulse width, the duty cycle of the pulse width modulated signal will be varied to cause this LED to output either a stronger or weaker light. Now, one of the problems with this experiment is that both the LED and the photoresistor have super fast response times, and therefore it turns out that the PID controller doesn't really have a chance to take and settle down totally because of these super fast response times. The duty cycle of the pulse width modulated wave is getting jittered, and we really can't stop the oscillations. You'll see the jagged signal we get out of this in a couple minutes when I show you. But it turns out that if we were trying to, say, control the speed of a motor, the motor has a much slower response, and therefore we probably get a flatter line when we look at the serial plotter of our set point. However, when we do this experiment with the light intensity, we get a jagged output, and about the only thing we can do is hope to take and make the excursions that goes away from the desired set point as small as possible. But to do that, you probably have to sit and play with the KP, KI, and KD values, and we don't want to do that. That's, you change one and you have to alter the next one, and so on and so forth. They're very interdependent upon one another. One thing we have done here is I've actually added a little capacitor over here to try to tone down the amount of, I guess I'd call it the dispersion of the waveform coming out of the, or the peak-to-peak amplitude of the waveform coming out of the serial plotter. or going on, being displayed by the serial plotter. The other thing we can do is we can play with this blue potentiometer here to try to take and make the thing a little more accurate. Again, with the alignment, notice if I move this around here, depending on where I place it, the LED maybe starts to flash and so forth. Here it turns out that you see it's kind of a nice constant light. So again, the alignment is critical to this, and every photoresistor diode is going to be a little bit different. So it turns out, again, the results of this are not going to give you a nice flat straight line. So when you first turn it on and download the program, what you should do is take and disconnect this yellow wire so the LED goes dark, and then check on the serial monitor what the ambient output is from the photoresistor. Then if you have to adjust this blue potentiometer to someplace around, say the output is for the ambient light is about 300 to 400, and then this thing will work a lot better. If I put this back in, now what happens is the LED comes back on. So again, this doesn't give a very intuitively obvious output. I'll try to show you the output in a second, but it turns out that it's not a nice smooth line as you might get if you're, again, fixing the speed of a motor or the flow of a liquid or temperature, for instance. Temperature can't change instantaneously, so you get a smoother output. The light out of the LED can change it almost instantaneously. Matter of fact, it's too fast. What we really would need is some type of filter or a PID controller program that would do filtering of the output. So what I'm going to do now is bring up the IDE, and once I do that, we'll take a look and see what we can see. So I'm going to take my camera and I'm going to go over here, and hopefully the camera will display or show you what's going on here. Down the very bottom here, we have the monitor, the serial monitor, not the serial plotter, and you can see the numbers bouncing around. You know, it looks like 600 in there every once in a while, 595 and so forth. I'm going to go and change this now, and I'm going to hit Tools and hit Parallel Serial Plotter, and now the serial plotter should come up. It hasn't yet. Maybe it's over here. Let's click on this guy. There it is. So here you take a look, and hopefully the camera will do justice to this. You might notice that over here 600 is kind of in the middle of this, and it kind of goes up to 620 down to 580, which is about equal on either side of that. If I go and tweak my potentiometer a little bit, I can maybe get the thing to settle down a little bit, but I don't know, it doesn't appear that's the case here. And I'm not having too much luck. But again, you can see that the average value is the 600. So again, not the best experiment, but you get the idea. You'll change the set point in the experiment, and you'll see how the average value tends to be around that set point. Okay, that's about all for this.